This video is for a new section that's been added into the new course J277, and it's all about structured programming. So structured programming is basically a term used to describe planning out your programs and how it can lead to efficient, logical and space-saving applications. So it's essentially planning out your program, giving it some sort of structure and making it more efficient in the process. One way of doing this is to use something called a structure diagram. Now, structure diagrams can help to show a larger program broken down into smaller chunks. You might remember this from a previous section that you should have covered in the algorithm section about decomposition. So decomposition is breaking things down into smaller chunks so that you can look at those individually. Sometimes this method could be called divide and conquer because it allows different people to work separately on the smaller problems. So let's look at a simple example because this will make it a lot easier to understand. So the larger problem that we have in front of us is to make a board game. Now, obviously this is a computerized board game. It's not a physical one. And this is going to be broken down into smaller modules. So each of these modules, we can use a subprogram for each one to perform that individual task. Then the main program can use all of those subprograms. So here we have a structure diagram, and it is for the board game example. So at the top of the diagram, we have the name of the program that we are looking at, which is the board game. Underneath, we've broken it down into separate sections. Now, there might be more than this, obviously, but this is just an example. So for the first little section could be the main menu, for example. So this little section here, without a main menu, the user of the game wouldn't really be able to do anything. So we need to have a main menu section. And in that main menu, we're going to display all the options. So I know as a programmer, I am going to have a main menu, and in that main menu, I'll be able to call all of these other subprograms. Now, we might also have things like moving the piece. So each particular person that plays the game is going to have their own piece, and we need a way of actually moving the pieces around the board. We've also got start a new game. So when the user actually clicks on start a new game, we need to do various things. So underneath, we've got allow name entry. So that could be to put all of the players that are going to play into the actual game. And then we need to actually physically add them to the game as well. So another thing that we could do is to save the scores. So at the end of each game, we could save the scores to an external file. And one other thing we could do is be able to load those scores back in and display them on a high score page as well. We could also have a subprogram to roll the dice that links into something that we've already looked at in programming, which is to use random numbers. So a little subprogram to load random numbers between 1 and 6. Finally, the game that I'm thinking of in my head is going to ask the user questions. So it's very similar to a lot of games that you play where you roll the dice, you move a few places on the board, and it picks a question for you to answer. So in this particular instance, we're going to choose a random question, we're going to display the correct answer, and we're going to add points if you are correct. So I'm sure there's other things that could be added into this, but it is helping me to break down this problem into smaller chunks. And it would also allow me to give these individual sections to different people to work on. So the advantages of doing this, it is far easier to program as the subprograms are smaller. So each of those little subsections that we just looked at different sections of programmers could work on each individual one. So people can work independently on those smaller tasks and they don't need to work as part of the larger group. Makes it a lot easier to test, so each person that's working on each subsection can test their little module and make sure everything works perfectly. And they can also alter or fix each module without affecting anybody else's work. Another major advantage is using all subprograms again. So at the bottom here, where it says can we use all subprograms, that means that when we've created one of these little subprograms, function or a procedure, we can use that again and again. And we've looked at that with our random numbers generator that we've worked on in the past. So this leads in nicely for code maintenance. If you are going to have multiple people working on a program together, it's really, really important that the code is maintained properly. So what we need to make sure is going on is that everyone working on the whole program overall understands what's going on in the smaller subsections. You should also be able to make sure that you change all of those individual bits of code without affecting the main program. So all of this together, if we are maintaining our code properly, allows successful collaboration between people working on the overall program. So let's look at some examples of maintainability, ways of maintaining our code successfully. So the first one, this goes without saying really, because a lot of things won't actually work without adding the indentation in. But one of the reasons why we have it is so that it's easier to read the code. So indentation is literally moving the code inwards so that it's easier to follow the program through. So in the example that we've got on the right hand side, we have on line 2 here, we are starting a count controlled loop, which is going to loop 10 times because the number in the brackets is 10. So this is going to run this code 10 times. So it makes it a lot easier by indenting the code within the loop. We can see which code is going to be part of that loop, which code is going to run 10 times. So underneath here, we've got indentation for lines 3, 4, 5, 6, all the way down to 17. This is all part of our loop. If you imagine thousands of lines of code, the indentation makes it really easy to see when a loop starts and when a loop finishes. We can also see another indentation again for where the selection starts. So on line 6, we've got a little bit of selection, and that selection is showing that this condition needs to be met in order for this code to be run. So the main idea behind indentation is that it allows you to flow through the program a lot easier. It also allows you to spot these things. So it allows you to spot iteration is in the loops, and it allows you to spot any selection that's being used. Another example of maintainability is using comments, and this is probably the most important one for anybody collaborating on a project. So anytime you are working on something together as part of a team, it's really important that you understand what is going on in the program and why they might have done it. So 2 ways of doing comments. You can either have single line comments or multiple line comments. Single line comments are the one that I use most frequently, and it's just a way of adding in a little bit of kind of context as to what's going on during the program, and you might be able to give someone a little bit of explanation if it doesn't automatically stand out of what's going on. So a comment is used to help any programmers understand what the program is and what is actually happening. Finally, really important one is to use sensible variable names. I've met a lot of kids over the years that can really program very, very well and very successfully, and they understand exactly what's going on. But when somebody else is looking at their program, it's not apparent exactly what they're doing. And sometimes that's because they use variable names that is sensible to them, or they might understand what it means, but it's not always obvious to anybody else that's reading through. So for example, instead of using like the letter A or X or Y, we can use actual words or names that make sense. So you could use volume if you were wanting to work out the volume of a shape, or you could use width when you were talking about dimensions. Even though it's not as efficient in terms of memory space, it is a lot easier for people to understand what's going on. Also, if you're using things that are going to be returned back to a main program, then using a sensible name with comments explaining what you're doing is going to make it a lot easier for those people that are working on the overall program. So that's it for this extra new topic that's been added into the exam. Hopefully it's useful to you. If you have any questions, don't hesitate to get in touch.